In this video, I want to have a look at the natural logarithm. So we know that e is the most natural base to use when we're looking at exponential functions in calculus. And similarly, e is the most natural base to use when we're looking at logarithms in calculus as well. So in this video, we're going to have a look at the function y equals log to the base e of x. So first off, let's have a look at what that function looks like. So if we jump over to GeoGebra, we have here this green line shown is the function y equals e to the x. So that's our exponential function that we've already been looking at. Now in red, we've got this function of the natural logarithm, so log to the base e of x. And I want to compare some of the features of those graphs. So we know that our exponential function has an asymptote at y equals 0, so along that x-axis. Our log function has an asymptote along the y-axis instead, so it has an asymptote of x equals 0. Our exponential function has a y-intercept of 1. Our natural log, or any logarithmic function, has an x-intercept of 1 instead. And actually, these functions are really closely related. They're actually reflections of each other around the line y equals x. There's a few things we need to know about the natural logarithm. So log to the base e of x is often just written as ln x, so the n stands for the natural logarithm. So if you see ln x, it just means log to the base e. Now in your textbook, you just need to be careful because in this chapter, they just write log of x and they mean log to the base e, even though often log is used to represent log to the base 10. So in your textbook, it's not doing that, it's using to the base e if it just says log. The next thing is that logarithmic and exponential functions are inverses. So if we have log to the base e of e to the x, then that's just going to be equal to x. And the reason for that is that with our log laws, that x could come out the front. So we'd have log x times log to the base e of e, and this log to the base e of e is just 1. So this will just cancel down to give us that x. And if we do it the other way around, if we have e to the power of log to the base e of x, that'll just simplify down to give us x as well. Now I want to have a look at how we can differentiate that natural logarithm. So if we've got the function y equals log to the base e of x, we could rewrite that to be x equals e to the power of y. Now, if we differentiate that, we could differentiate x with respect to y, and we know that if we differentiate an exponential, it just ends up being itself. So we just still get e to the y. But we can replace that e to the y because we know that e to the y is just equal to x from our original function. So that means that dx dy is equal to x, so the original function, the derivative, is equal to itself. But we actually wanted to find out what dy dx was. So if we write the reciprocal, we would end up with dy dx is equal to 1 over x. So to summarize that, if we differentiate log to the base e of x, we end up with 1 over x. All right, so that's an introduction to the natural logarithm.